So hello, welcome to part 3 of this CASIM video tutorial series on Arduino, Pure Data and Super Collider. And I'd like to begin with a review of what we achieved. Just a summary of what we did in the last video. Or the last couple of videos, built our own breadboard Arduino, made some force sensing resistors, connected them to Arduino, and then wrote some code in Arduino software. And the code begins by summing the readings from FSR1 and FSR2. It does that 20 times. Then it takes the average of those readings for a simple low-pass filter. We then have to do some mapping and constraining to ensure that whatever values we're getting off the FSRs are constrained between 0 and 255 for two reasons. One, we're controlling LEDs and they only respond to 0 to 255 range. Then we serial.print the ASCII code 97, which is the character A. Then we write our first FSR as an 8-bit byte. Then we serial.print ASCII code 98, which is the character B, and then we serial.write the second FSR value as an 8-bit byte. And we can now dispense with the Arduino software. And how we capture that information in Pure Data is via the COM port object. And we discovered, using the devices message to the COM port object, that my microcontroller shows up on port number 32, and we know that the baud rate is 38400. So we hardwired those into the COM port object as argument 1 and argument 2. Then, using select 97 and 98, we can route discrete sensors. That's force sensor 1, force sensor 2, and that's as far as we got last time. Now it's time to get interactive, build an interactive synth. And the quickest, simplest thing I could think of was a chaotic FM synth. As I said earlier, we're not going to have a detailed tutorial description on sound synthesis techniques. I'll rattle through this fairly quickly, but I will explain what's going on. And in order to process audio, we need to turn digital signal processing on. And we can do that from the console window via this toggle GUI or this tick box. But we can also do it from within our own patch. If we create a message, begin it with a semicolon, and that indicates that we're sending a global message. And PD means we're sending to the PD software itself, and we simply say DSP $1, $1 being the variable, and a toggle box, Control-Shift-T or Command-Shift-T, outputs, it's a GUI object that outputs a 1 or a 0 when I click it. And if we observe the console window while I click that toggle, you'll see that we can turn audio on and off from within the patch. So we'll turn it off for the time being while I talk a little bit about FM synthesis. And essentially, FM synthesis is vibrato at high frequency and high depth. Well, what is vibrato? We have a center frequency or carrier frequency, and that frequency is modulated by the output of a modulating oscillator. And there are a number of control parameters that we can introduce to that simple equation. But instead of using equations, I can simply draw the synthesis engine or put objects. I can build the synthesizer, and I think it's arguably clearer to see. So Command or Control 1 to create a blank object, and we need an oscillator, a sine wave oscillator. And we need to control its frequency. It's the center frequency of our hybrid FM synth. And I'm going to do that with a signal, and I'm going to do it with the line object rather than the signal object. Sorry, signal object. Because I want to smooth out changes over time. I don't want the frequency to jump between values. So if we send the line object a message, Command Control 2, and I'll say $1, go to that value in 50 milliseconds. And the left input to the OSC tilde object is where we input the frequency value. And in this case, it's going in as a signal. So to get audio output, Command Control 1 for a blank object, DAC for digital audio converter. I'm going to do a little bit of scaling. So I want to multiply the final output, multiply tilde. All objects whose names terminate in tilde are audio rate objects. They output or they receive and output audio signals. Multiply by 0.3 so we don't blast our ears or speakers. Turn audio on and raise the center frequency. And just to demonstrate how the line object works, I'll change the 50 milliseconds value to 2.5 seconds. And you'll hear a jump, a slide, sorry, not a jump. I type in the number 5000 as a frequency value, it should slide up to that value. And indeed it does. Let's come back down to reasonable range, 300. Now I want to control the overall volume of this patch, the output. So I will take a copy of this line object, delete the 0.3 because it dictates that the right inlet will only respond to floating point numbers. I want a signal, so I need to delete that number value I had as an argument. Oh no, don't connect it directly because I'm going to use a V slider. So I can do that from the put menu. I could say put V slider, but I could equally Command Control 1 and type the word V slider. It gives me the same object. His range is normally 0 to 127. We could do two things. I could go into right click and go into its properties and change the minimum and maximum, or change the maximum to 1. Or I usually do this, is I know that multiplying by 00787 normalizes that range between 0 and 1. So now I have a volume control. And I need to change those two values. They're 2.5 seconds back down to 50 milliseconds. There we go. Happy days. So we have a center frequency for our sine wave oscillator, and we have an amplitude, overall output amplitude control. And we discovered that we can modulate this frequency value to create vibrato. So we need a plus tilde object. What's coming out of line is a signal value that represents the frequency that we want our oscillator operating at. And if we add another oscillator to it, let's say at 7 Hertz, and listen to the output. Not a great difference. Why not? Well, let's inspect what's coming out of this plus tilde, and we'll use the snapshot object, and it needs signal input, but it also needs a trigger input, and we'll use the metronome object at I don't know, say 50 again. Need to initialize the metro. When I turn this toggle on, snapshot will start putting out floating point numbers that represent the signal we're getting from the line tilde object up here. So the center frequency is fixed here at 414, but we see down here that let's change that 50 to 100. It's modulating around 414. Oscillator, sine os, puts out a sine wave in the range -1 to +1. Therefore, 414 is being modulated in the range 413 to 415. Subjectively anyway, we can't really hear any vibrato. We need to increase the range of this modulating oscillator. Let's multiply it. Multiply tilde by 10. So instead of 414 being in the range 413 to 415, we'll have 404 to 424. We'll be adding and subtracting value of 10 from 414. Let's listen to it. Now we can clearly hear our vibrato. So that's vibrato done.